next section will look at data joint table syntax and Spyglass conventions through the lens of like, what does it look like to actually look at a Python file within Spyglass within whatever other data joint project. In general, we can break up Python script into like Frontmatter and then actual definitions. The Frontmatter are these like imports and schema declarations. Anyone familiar with sort of Python more generally will know that like imports can pull code from other places. The schema declaration is the portion of the Python code where we tell data joint where on SQL these tables will live, which has some implications for the general permission structure that most databases use. Of the possible ways to import code from other places, you can do the full package import, you can do a sub-package or individual class or function import from an existing package. You can do a relative import. The imports that have the periods in front of them designate that you're importing from a local file relative to where you are now. And then this portion that says dj.schema will just pass a string to data joint as this schema object. That schema object gets used as a decorator, as we'll see on the table declarations. But what this is saying is of the places on MySQL where you could store a table, the general convention is unfortunately a mismatch of naming, but in MySQL terms, you say there is a SQL instance, and then in that instance, there are databases. It's unfortunate that the sort of general convention of like what is a database generally conceives of the whole thing of MySQL to be one database. But a MySQL database is a subset of the tables that share this label, this schema label. In the case of Spyglass, which you'll often see is DJ schema, and then it'll say common underscore something, common NWB file, or behavior underscore v1 underscore MOSIC to give you an indication of where this table exists within the broader Spyglass package. The reason this is relevant, the reason you would want to be careful about what you label your schema declaration as is because when you set up a MySQL user, in general, you do so with permissions to specific schema prefixes and or specific databases. So when I set up a user, I give them permissions to access, insert, delete, all these things on the common prefix, on the behavior prefix, on the LFP prefix. And I also give them full permissions to their username prefix so that I encourage them like, hey, if you're developing tables, if you want to attach and make your own custom pipeline, use your username here, and I will know that those are yours. There are some features of Spyglass that like crawl across the database and look at like, oh, what's going on? So if some tables pop up unexpectedly on shared prefix like common that I don't expect to be there, it becomes a little more annoying to deal with as someone trying to develop those more advanced features. But yeah. Permissions are tied to prefixes. We have shared ones. If you call a table, for example, so import Spyglass common video file, if you call a table and then ask for the full table name, what you'll get back is a string with these backticks around it, but a string that can be predictably declaration said at the time the table was declared, and then some form of what's called snake case string for the table name itself. Snake case refers to, yeah.
You got a question from Gabby?
Oh, sure. If you don't mind, I'll just get through the table naming stuff first. Yeah. snake case has underscores as opposed to camel case with capitalization, and the Python camel case table name can be sort of one-to-one translated to the snake case name predictably, such that if I have this table name, I'll be able to get back to the Python table name. But yeah, sorry to make you wait, Gabby.
No worries. Yeah, I had a question in terms of the the username schema, like if we're
Hmm.
making custom pipelines. And I guess in the case where I want to make a custom analysis that isn't just used by me, but it's used by, broader people in the Gillespie lab,
Hmm.
is the proper thing to make a distinct schema for the Gillespie lab and then insert all the custom stuff there, or should I be using this custom username situation?
Yeah, the way we try to handle that is to declare a prefix for a given project. So there's Spyglass that has its like sub package prefixes, common LP, whatever. Um, Stephanie is working on a hex maze project that has some tables unto itself. So we've gone and declared HEX underscore as a project prefix. And then I, as the like database admin person, have given specific people who I expect to be working on that project specific permissions for like, all right, these are the people I expect to insert into tables on the hex prefix. These are the people I expect to declare new tables or drop existing tables on the hex prefix. Yeah. I have a bunch of scripts for doing that kind of thing, but it doesn't have, you could do it. It is much easier to do just logging into MySQL directly. So I have a bunch of .SQL scripts that I use to manage that kind of thing. Yeah. Cool. So also in the context of a data joint Python script, or all the classes, each of which corresponds to a, in general, table somewhere on the SQL side. The structure for a table in general is to have this schema decorator. Decorator is anything in Python that has this @ symbol before it and typically occurs before a class or a function that has some sort of changes to some extent the behavior of that class or function. In this case, the schema decorator does the job of checking if the table exists, attempting to declare it if it doesn't, those sorts of connection things. In Python syntax, the class and then class name is typically camel case with these capitalization, um, and then these parentheses that tell you what this class inherits. So if you looked at data joint tutorials, it would be parentheses dj.manual, dj dot imported, computed, part, whatever. For the case of Spyglass tables, the way that we have chosen to basically take some advanced features and distribute them to all Spyglass tables at the same time is to include this Spyglass mixin. There's a whole documentation page that goes through all of the things that that is doing. For the most part, it is attaching convenience functions that we found sort of tables to be lacking. You know, if the database is slowing down and you want to check, all right, what is going on with this table on the database that might be causing slowing, there is a convenience function that helps support querying SQL to see what kind of processes this table is involved in. There's a function for looking at to just take a string of like a file restriction and add in the wildcards for you to, I found myself typing over and over again, and NWB file like this thing. So added a convenience function there. The way that that gets declared you have to put the Spyglass mix-in before the data joint table, so it loads those functions in a distinct class inheritance order. Manual, computed, imported, those are the data joint with they call table tiers. Really, it's a set of 4 or 5 classes on the data joint side that do slightly different things. The difference between them is sometimes implied and not rather than enforced. So manual tables are intended for manual population. They are declared with the expectation that you're going to insert and or delete every row yourself. Lookup tables have an additional structure in addition to manual tables that allows you to put in a Python content attribute to say, on declaration, this is what I expect this table to contain. Generally useful for parameters for tables that you don't expect to change very much and just expect to contain like, all right, these are the 4 ways to do this thing. The user will pick between those 4 when they insert into the manual table below. Computed and imported tables both give this auto-populate feature. So I mentioned before that data joint has this, I don't know, one of the things that makes it special among competitors is to associate a Python function with a table definition. Computed and imported tables are where you do that. The implied unenforced difference between them is that computed tables look upstream for their information and then run the compute versus imported tables look on disk. In general, Spyglass will declare an imported table for any place where we think someone is going to run the like insert from NWB type function versus computed is any place where we expect someone to look upstream for a set of like files and parameters and then run a calculation and probably declare an analysis NWB file. Part tables differ from these other 4 in that they are always associated with a master table. So either a manual or a computed or an imported table will have sort of one entity, and then it can have multiple parts associated to give a many-to-one relationship. So if you had sessions and each session you knew had some number of trials, you could declare a session table with a trial part table that always referred back to that session. The unenforced suggested behavior of part tables is that you should be inserting and deleting all of your parts at the same time. So whether something should be a manual table that connects to another manual table or a manual table with a part, that question ought be, according to data joint, prescriptive documentation, that decision should be made based on whether or not you know all of the parts that will exist at time of insert. It makes for a convenient way to make sure you're deleting all of your trials at the same time as you're deleting your session, which ought happen regardless of how you structure it. But for the case of Spyglass, it often makes sense to conceive of a grouping of objects paired together at the same time. So you can have a set of electrodes that were used at the recording of your session, but maybe you're interested in an electrode group that is, this subset of them. And you want to declare that group and then run analyses based on that group without ever considering the items not present in that group. So we use a master part table relationship to carry that notion of a group downstream through the pipeline. Spyglass has conceptual table types that in general refer to what will take place over the course of a schema, what will take place over the course of a pipeline. So in general, there is some data table somewhere that is the origin point for this pipeline. And it's kind of cyclical in that it will output to another sort of data or analysis type table at the end. But we inherit data from someplace. Early on in Spyglass, it is often from the NWB file or the session table someplace that represents the whole session, some notion of a file, and that will link somewhere downstream to a selection table. Well, I'll cover first. The other thing that will exist in the course of a schema is a parameter table, some sort of set of key value pairs that will define the structure of an analysis, even if that is simply like, here are all of the pieces of information that go into the function that I'm pulling from a package that I've written to analyze this piece of data. The selection table is the staging where these pieces of information meet, where these it's the pairing of the upstream parameters and original data happen. This isn't a requirement in designing a data joint schema. You could skip the selection process entirely, but it allows for, or sort of, this design pattern encourages a more thoughtful, conscious, deliberate selection of, right, these are the sessions for which I want to run these param sets in my analysis, a conscious pairing of those pieces of information. The selection table is usually the only inherited table for your then analysis, which is often a data joint computed to actually run that pairing for each row in the selection table, run this analysis. The pattern that doesn't exist, that analysis can then be treated as the data table for your next schema, for your next pipeline. The additional pattern on top of this sort of schema by schema set of data parameters selection analysis is a merge table. So year and a half, 2 years ago, Spyglass was faced with this problem of, we've done spike sorting this way for so long, and we want to keep these tables present. This is still a way that some subset of the lab wants to do things, but there are new people in the lab who want to develop a new version of spike sorting analysis. What do we do about that? You could say, all right, these things are incompatible. We've got to have two databases now. Or you could say, we need to phase out the first one and then declare the new one to allow for concurrent usage of spike sorting v0, spike sorting v1. We've added this class for merge tables that expects this pattern of a master table with just a merge ID in it. It's a pretty bare master table. And then part tables that reflect the terminal points of these different pipelines. It allows sort of places downstream of the merge table to be upstream agnostic as to the tables that they're inheriting data from. So it permits you to process data through spike sorting v0, put it into that merge part table, import through or run through v1, merge part table. And so long as those have all of the fields that would be required to run a relevant comparison, you can say what happened in these two different cases by attaching an analysis table to that spike sorting output table. And that output is our suffix indicating a merge table. Any questions about those conventions? It's this weird, like, not one-to-one mapping and juggling of different sort of conceptual notions, but hopefully it makes sense. Okay. Yeah, an analysis can be structured in many different ways. Just because we have these conventions in Spyglass doesn't necessarily mean that you need to in the context of a custom analysis, but it will mean that I'm looking for them if you ever want to contribute to Spyglass, just as a way to make it easier for a new user to apply the same conceptual notions across different places. I suppose this would have been helpful while I was talking about it earlier, but yeah, this puts that in terms of a flowchart of like, this is this big schema box, has this parameter selection table, data from somewhere upstream, from somewhere else. That analysis gets fed into this merge part. This is me putting together like an ASCII graphics version thing. When you're using Jupyter, when you're using a Python sort of GUI interface, DataJoint has this DJ diagram class that will let you just pull diagrams for tables you're working with for schemas that you've imported. It's a worthwhile way of exploring subsets of tables. I wouldn't recommend trying to do it for all of Spyglass. That gets pretty big and unwieldy. But if you're just sort of asking the question of like, oh, wait, how did data get from session to here to there? DJ diagram, you can see in the documentation, it'll say, okay, sum the schemas you're working with, sum the tables you're working with, and that'll do a similar kind of boxes and arrows picture for you. Yeah, Gabby.
Um, does I forget, does the DJ diagram also tell you like what type of table everything is? Like, is that somewhere?
Yeah.
Okay,
The docs aren't great, but I think it's like a computed table is red, an imported table is blue, manual's green, one of them's gray. Yeah.
gotcha. I never knew what those colors meant, so that's helpful.
Oh, sure. Yep. There's somewhere in the documentation, or maybe it's buried, maybe it's just in a doc string. It'll say what the colors mean. It'll say what the arrow weights mean. So a dotted line means something different than a heavy line, means something different than a thin line. And yeah, I'll be talking about the different kinds of table connections in the next section. So we can revisit and I can Google, what the different lines mean in the diagram when we get to that point. When it comes to declaring a table, so jumping back to this notion of like, I'm talking through what it would look like to read a Python script. This is the kind of thing you would expect to see. This is maybe a larger table than some of them in Spyglass, a shorter table than some of the custom tables I've seen. But we've got that schema declaration. We've got this, is my mouse visible? Is that, yeah, okay. We've got this Python class name that's going to be the primary way we interact with the table. We are inheriting these multiple different classes. In general, in Python, you should be adding a doc string to any class or function you declare as a way of, documenting your code as you go so that you can write like help my table and see the thing you wrote in the past. Data joint, sort of a big chunk of data joint is how to write a definition that is SQL compatible and will sort of do the things you want it to do in SQL with just a string in Python. So this first comment is what's going to be used as your header for the table when you call it. Uh, each row that does not start with the hash comment symbol will be a column in the table, a field in SQL terms. Primary and secondary keys are going to be separated by these three lines. Anything above that is primary, below that is secondary. The structure of any one of those lines is going to be the name of the field, the colon, and then the data type for that field. Anything you put here that is also a SQL data type will be accepted. So there's int, there's tiny int, there's big int, there's blobs, long blobs, medium blobs. What you'll see for the most part across Spyglass is a lot of int and varchar. So char with a number in it means please allocate memory for exactly this many characters. Varchar, variable characters, says please allocate memory for up to this many characters. And so that's a little more memory efficient if you think that you'll be under that character limit for the most part. If you know you'll be exactly at some specific character limit, I think there are benefits to using char over varchar. But for most of us, it is often the case that we're just adding a string to this row in the table, and we don't know at the time of declaration exactly how long it'll be. This jumps ahead a little bit to custom table declaration, but the lower you can keep this number, the better, and we'll get to why later. UUIDs are essentially randomized character strings designed to be independent, designed to have a very low likelihood of reoccurring. So merge IDs are set as UUIDs so that it's a random string because this data is sort of auto-generated and we want it to be independent, and we want this merge ID to essentially mean nothing but be unique. Blobs are any place where we're inserting some arbitrary amount of data into the database. For the most part, Spyglass doesn't really do this. It does in some cases where it's like, here's a Python dictionary for a params table, for an analysis pipeline, for which we don't know how this dependency is going to change. So we're just going to give it a Python dictionary and expect that that dictionary, when loaded, will be all of the necessary and some of the optional arguments for whatever function we're calling on a dependency, acknowledging that versions of dependencies might change, and for less rigorously managed dependencies, the argument structure and the specific names of things might change over time. In Spyglass's case, what's more often true for like handling actual large amounts of data is that we'll be adding an analysis NWB file and storing actual data in analysis NWB files as like analysis checkpoints throughout the pipeline. This arrow indicates a foreign key reference to another table. That can occur by just saying like arrow NWB file. Whatever occurs here should be a valid name in the Python namespace of this Python file. So if I ran from Spyglass common import NWB file, this arrow would be valid because I would have that object. But if I instead had at the top of my file from Spyglass import common as SGC, instead I would write here hyphen caret sgc.nwb file in order to tell Python this is, or in order to tell data joints definition parser where to find this object. It's possible that on table declaration you'll see something like, this is not a valid name in the namespace, and it'll be because the prefix didn't line up. In some cases, some Python linters and like the tools that clean up your Python files for you might get rid of an import that it doesn't see actually being used in your file. So more aggressive linters like rough will see like, oh, you imported NWB file, but you didn't actually use it because rough is not looking at table definitions. I, as like a weekend project, made a data joint linter that like, if you want to use, great. But it parses uh, uh, table foreign key references and then makes sure that the way you import has the relevant signifier to tell linters to ignore that piece. So here from Spyglass comment import NWB file, I have no QA 401. What that does is tell some aggressive linter like Rust, Rough, which you may not have. Hey, I know I'm importing this. I know I'm not actually using it when you analyze the file, but I know why I'm importing it. Um, so while I do recommend rough and linters and black and all these things to help keep your Python files consistent, this is sort of the one caveat of, managing table declarations through just these long multi-line strings. The last thing I'll say about table declarations is that you can import, have a foreign key reference that renames or aliases a field of a table you're referencing. So if I wanted to blind myself to, we'll look later at like a subject blinding table that uses this purposefully to take something that's like an actual ID and then rename it as, I don't know, this is the interval list, an interval list name from the interval list table, but here I'm labeling it as like artifact removed interval list. Any questions about table definitions? Yeah, go ahead. Gabby?
Oh, sorry. I
Yeah.
missed that. Yeah, so question about the like when you reference some foreign keys from another table, is it specifically inheriting the primary key, or is that just depending on like how you actually set it up?
Yep, a foreign key says, give me all of the primary keys from this
I
table.
see. Okay, so there's no way to access like, or there shouldn't be a need to access like secondary keys because that would, I don't
Yep.
know.
If you're trying to access secondary keys, it's probably the case that either the table shouldn't be designed that way, which like happens, or as sort of is more likely the case in just looking across Spyglass files, you'll import the primary key, and then when you need that during like your make function, you will run a join. You'll join two tables to get the full set of information across both. Uh, because you want to reference that secondary key, that whatever it is that you had in mind, you'll first take the primary key and then call the secondary information via that primary key.
Okay.
Or another way of saying it is like because that primary key uniquely identifies one row, then you know what, like database wise, you have defined all the secondary keys related to it as well. You just have to do the step of fetching it from that table or joining.
Gotcha.
Mhm.
That makes sense.
Yeah, I often have a method when I'm designing tables of just like fetch parent of it runs the join of the current table, or sorry, it runs the join of the parent tables and then restricts by the key, so that I have access to all of that information. Yeah, as much as I'm covering data joint table declaration syntax here, I don't really have a discussion of what it means to join and restrict a data joint table using those like asterisk and operators. Um, Happy to cover that. Don't quite have a slide for it, but let's see, if the questions arise when we get through this, and I'll try to point them out when we get there through some of these table definitions. Yeah. So speaking in more general Python terms, any class can have a number of methods attached to it. Uh, uh, I'm not recalling the like specific definition of what method versus function means, but I think method just refers to a function that is attached to a class. Um, the property decorator just allows you to call that that piece without a call that method without without using the parentheses that would indicate you're running a function. So subject blinded dot property will return some piece of information by running this function. If it instead was a bare function that didn't have property, I would need subject blinded dot property open close parentheses to indicate the running of that function that, in that case might accept an argument. A static method is one that does not reference the information contained to the class. So a static method is a piece that really doesn't care about all of the other things happening in the class, and it might just be a helper method that is relevant to this class. A class method cares about the class and not the instance. So you've probably had the experience before of from Spyglass comment import subject, and then you'll run subject and it will print out something that says subject table declared here. And what you instead need to run is the open close parentheses to get the table view from subject. The that is instancing the class that sort of declares this new bare instance, and the default is to run a preview of the table. We can circumvent the need to instance in this way by decorating, where'd my mouse go? Decorating the table with this class method. The bare class method, separate words, assumption is that the method itself will have access to the table information have access to the class information and an instance of that class rather than the general version it inherits. So this is an example where I'm using a restriction to restrict the parent table that, I haven't provided the definition, but this table is foreign key referencing, and I'm using some way of hashing that key to provide a unique identifier for the subject as a subject blinding approach, and then inserting that into the instance of the table itself. Happy to exit from these slides and pull up a version that actually has the full table definition if we're curious about investigating more of this notion of like what each of the methods do. As an example, parameters table, I mentioned that this DJ lookup table tier permits the declaration of the table contents via this contents attribute. This just means that whenever the table is declared on a new database, by default, this data will be part of the table. This is an example of, a varchar params name as the unique identifier, and then a blob that has this like set of key value pairs that we expect to use in an analysis. A lot of Spyglass params tables have this like insert default method that you'll see just out of a convention for a time before Spyglass was using lookup tables to insert this contents information. A thing that you would probably never encounter but is worth knowing is that the table tier that data joint thinks the table is will determine the name of the table on the SQL instance. So I showed before that table.fullTableName will show you the schema and then the table name. whether it has an underscore or a hash symbol or something else before the table name indicates, is this a lookup table? Is this a manual table? What is it? Such that when we sort of pivoted a little bit with Spyglass and added params tables as lookup tables, some of the earlier ones were just manual tables, and it's a way of keeping things more standardized. To give a more concrete example of like what it looks like in Python terms to have a selection and an analysis table, I think this is the most bare bones version of having my analysis selection inherits from the mixin. It inherits from DJ manual as that table tier, and then just has these foreign keys that says this manual table accepts the pairing of the primary keys from subject blinded from my params, and will select a subset of all possible combinations of those things, such that when I run my analysis dot populate, it will run the relevant make function for each of those selected pairings of rows from those parent tables. It's worth noting that in the Python syntax, you don't need the schema decorator on your part table. It's just indented below whatever its relevant master is. And then when you declare a part table, it's optional to say arrow and then just write master as sort of a keyword indicating the table it's paired with, or to actually write the table name, and data joint will consider them the same. Adding the schema declaration, I think, has a pretty relevant or pretty informative error, so it's usually pretty easy to circumvent. Yeah, any questions on